Today we're going to be looking at polynomials. So let's first look at different types of polynomials. So a monomial, if you think of the word mono, means one. So a monomial has one term. And if we're talking about terms, we need to remember that terms are separated by addition or subtraction. So a monomial only has one term. A binomial, if we think of the word bi means two. So a binomial has two terms, and those terms are separated by addition and subtraction, and we cannot combine them because they are not like terms. Trinomial, tri means three, so three unlike terms. A polynomial means four or more terms. And again, these are unlike terms. Let's look at degrees. So the degree of a monomial is the sum of all the exponents within that term. So 4x to the third. Our exponent is x to the third, so our exponent is 3. So our degree is 3. Here we have 4x to the third y squared. We have two powers here, so we're going to add our exponents. So 3 plus 2 gives us 5. So we have a degree of 5. The last one here, we have 4x to the third, y, z to the fourth. So we're going to add our exponents here. We have a 3, we have a 1 for y, and a 4 for z. So 3 plus 1 plus 4 gives us a degree of 8. So that's only when we're talking about a monomial, so one term. If we're talking about the degree of a polynomial, we need the largest degree in that polynomial. So you're going to look at the degree of each term, and then it's going to be the largest. So here, this first term, we have a degree of 3 plus 2 gives us 5. Our second term, we have a degree of 2 and our invisible 1, so degree of 3, and we have a degree of 1. So our degree of our polynomial is going to be the largest one, so we have a degree of 5. So let's look at some of these examples here. So we have expressions, and we need to know the type of polynomial. So its name and then its degree. Let's start off. Our first expression here, we name it by the number of terms. So we have 3 terms here. So we have a trinomial. And our degree would be 3, the highest exponent. The next one, we have 4 terms. The 4 terms make a polynomial, and the degree is going to be the largest exponent, which is 6. The next one, we have 2 terms, so it's a binomial. The highest exponent would be 1, so our degree is 1. The next one here, we have 1 term, so we have a monomial, and the degree is 1. The next one has 1 term, so again, it's a monomial, and there is no exponent, there's no variable. Since there's no variable that has an exponent, our degree is 0. So any constant is going to have a degree of 0 every time. The next one here, we have 5 terms, so 4 or more terms make it a polynomial. The largest exponent is 4, so our degree is 4. The last one here, we have 3 terms, and 3 terms make it a trinomial with a degree of 2. Okay. Now, let's look at standard form. So when we're talking about polynomials, the standard form of them are going to order the degrees from greatest to least. So we look for the largest exponent, which is 5. So we're going to have 6x to the 5th. Then after 5 comes 4, so we have plus 4x to the 4th. Then comes 3, which here we have a degree of 3. So 5x squared y, and then lastly we have minus 7, our constant. Let's look at the next one. Largest exponent comes first, so we have 6x to the 5th. Then we have 8x to the 3rd. Then our x squared. Then our x, don't forget to bring the sign with it, so minus 7x. Lastly, plus 5. Now, a leading coefficient is a coefficient of the first term when it's in standard form. So here, if we're looking at the equations above, the expressions above, the leading coefficient would be 6 here, because it's the first term in standard form. And again, it'd be 6 here. The leading coefficient, after it's in standard form, it's the first term. Okay, let's look at some examples. We have some expressions and we need to write in standard form. So, highest exponent comes first. So we have 2x to the 3rd. Then we have minus x plus 4. Our leading coefficient after it's in standard form is the first term, so it's 2. The next one, largest exponent, negative 3x to the 6th. Then we have plus 4x to the 3rd plus x squared plus 2. Leading coefficient is negative 3. We have a constant and then an x. So our x comes first. So minus 5x, I'm sorry, let's try that again. Negative 5x plus 3. Leading coefficient is negative 5. Standard form, largest exponent first, so that would be x to the 4th, but bring the sign, so it's negative x to the 4th. Then we have plus 3x to the 3rd, plus x squared, plus 4x, minus 8. Leading coefficient, we have a negative, that's a negative 1. And then the last problem here, the expression itself is already in standard form, so we can just go in and rewrite it. And our leading coefficient is 2. The last thing we are going to look at today is combining like terms. So early in the year we did this, but we need to review it because we have to combine our like terms before we can write it in standard form, before we can name the polynomial. Our terms need to be combined. So we need to have the same variable and the same exponent for them to be like terms. This first problem here, we have 4x and 6x, and then an 8x squared. We have an exponent of a 2, so it's not a like term here. Our 4x and our 6x are like terms, so we add them. 4 plus 6 gives us 10x. Bring down our 8x squared. And the last thing we're going to do is rewrite it in standard form, so our largest exponent comes first. There we go. Look at the next one. Our like terms here is negative 4x and negative 6x. So when we combine them, negative 4 minus 6 gives us negative 10x. Bring down our negative 8x squared. Then rewrite it in standard form. So our x squared needs to come out front. The next one here, 4x squared plus 6x minus 8x squared. Our x squares are our like terms. So we need to combine them. 4 minus 8 gives us negative 4. X squared, bring down our plus 6x, and then it's already in standard form. Our last one here, negative 4x plus 6x squared minus 8x squared. Our x squares are like terms, so I combine them. 6 minus 8 gives us negative 2x squared. Bring down your negative 4x. So that is your lesson today on polynomials. Please reach out if you end up having any questions.